There's a number that took human civilization roughly 4,000 years to actually believe in. It's not a big number or a complicated one. It's the smallest number there is, 0. And without it, there's no algebra, no modern accounting, no internet, and no device you're watching this on. For most of recorded history, if you needed to write nothing, there simply wasn't a symbol for it. Ancient number systems could write 1 sheep, 10 sheep, 100 sheep. None of them had a way to write 0 sheep. So how did some of the most advanced civilizations in history run empires, calendars, and trade networks with a number system missing an entire number? And why did it take almost 4,000 years and one specific text written in the year 628 before anyone actually fixed it? Early counting was just tally marks, 1 scratch per sheep per day per coin owed. The Egyptians and Babylonians built far more sophisticated systems on top of that. But the same gap remained. Nobody had a symbol for an empty amount. Rome inherited that exact blind spot at imperial scale. A civilization spanning 3 continents ran its numbers on just 7 letters: I, V, X, L, C, D, M. Try multiplying XLVII by XII using only those 7 symbols, with no place value and nothing to hold an empty column together. It's not just hard, it's close to unworkable directly on paper, which is exactly why Roman merchants and tax collectors leaned on a physical counting device, the abacus, to actually do the arithmetic. Numbers for Rome were something you recorded after the fact. They weren't something you could easily calculate with. The system was so unwieldy at scale that a single year on a Roman monument could need 4 or 5 different symbols just to be carved. The fix didn't arrive all at once. It came from India in careful stages. Around 500 CE, the astronomer Aryabhata used a placeholder inside a positional number system, a symbol meaning this column is empty, the same trick Babylonian scribes had used 1,000 years before him. A birch-bark manuscript buried in a field near the village of Bakhshali, in what's now Pakistan, used a simple dot for that same placeholder. In 2017, radiocarbon dating at Oxford's Bodleian Library suggested some of its pages date back to the 3rd or 4th century, even older than Aryabhata. But a placeholder is only half an idea. It marks an empty column. It still isn't something you can add, subtract, or multiply. The real question nobody had answered yet was simpler and stranger. What happens when nothing gets treated as a number, exactly like 1 or 10 or 100? India already had a word for that kind of nothing. Shunya, meaning void or emptiness, a concept borrowed straight from philosophy, centuries before it became a digit. In the year 628, an Indian mathematician named Brahmagupta answered that question directly, in a single text, the Brahmasfuta Siddhanta. He wrote down the rules. A number plus 0 leaves that number unchanged. A number minus 0 leaves it unchanged. Any number multiplied by 0 becomes 0. For the first time in recorded history, 0 wasn't a gap in a sentence or a placeholder in a column. It was a number sitting on the same number line as 1, 2, and 100, with arithmetic rules of its own. Brahmagupta even tried to work out what happens when you divide by 0. He got that part wrong, but he was the first person on record willing to even ask the question. That's the turning point. Not a battle, not a bridge, a page of rules written by one mathematician that quietly made modern arithmetic possible. The idea didn't stay in India. Arab scholars encountered these Indian numerals within a couple of centuries, and by the 820s, a mathematician at Baghdad's House of Wisdom, Muhammad ibn Musa al-Khwarizmi, wrote a treatise explaining the system so clearly it carried across the Islamic world. His own name, Latinized, gave us the word algorithm. The title of another of his books, Algebra, gave us the word algebra. 0 reached Europe through an Italian merchant's son, Leonardo of Pisa, better known as Fibonacci, who learned the system from Arab traders in North Africa and published it in 1202 in a book called Liber Abyssai. Europe's reaction wasn't gratitude, it was suspicion. In 1299, the city of Florence banned these new numerals from official bookkeeping outright. Officials argued a 0 could too easily be altered into a 6 or a 9, perfect for fraud. It took another 2 centuries, and the arrival of the printing press to standardize how the numerals actually looked, before merchants and governments finally gave in, because doing business with 0 was simply faster. And today, that same number is the reason a computer can exist at all. Every photo, message, and video you've ever sent is stored as a pattern of 0s and 1s. Every transistor inside your phone is really just answering Brahmagupta's question, billions of times a second. Is this 0, or is it not? Even the graph paper behind Descartes' coordinate system and the calculus Newton built a few decades later both anchor themselves to the same fixed point. 0, the origin everything else gets measured from. 0 was never really about counting nothing. It was about proving that nothing could still be something worth writing down, a number with its own rules, sitting quietly at the center of every other number. The next time your phone loads a page in a fraction of a second, that speed is running on a number one city government once tried to make illegal. Every video on this channel is built around one idea, one pivotal moment that quietly changed everything, explained clearly in under 15 minutes. If that's useful to you, subscribing means you don't miss the next one, and there's always a next one. And if this video changed how you think about something, even a little, hitting like is what tells YouTube to show it to someone else who needs it too. If this one was worth your time, there's another turning point video waiting for you right there.